Exercise 1.3. 5 identical charges Q are placed equidistant on a semicircle as shown in the figure. Another point charge Q is kept at the center of the circle of radius R. Calculate the electrostatic force experienced by the charge Q. Okay. Now here 5 identical charges 1, 2, 3, 4, 5. So they are placed in a semicircle. Okay. Now the radius of the circle is taken as what? R. Now here in the center of the circle another charge small q is kept. Okay. Now you have to find it out, the electrostatic force experienced by this charge. Okay. Now for our convenience I am going to name the charges as 1, 2, 3, 4, 5. This is q. So here it is 1, this charge is 2, this is 3, this is 4, this is 5. Okay. Now what is the force experienced by these charges? Okay. Now the force experience, you imagine there is nothing is given there whether it is a positive charge or negative charge. Now we are going to take it as a positive charge. So the force experienced by this charge Q1 is away. So it is away means, so the force experienced by that is F1. Okay. Now the force experienced by the charge 2 here. So this will be along this direction. Okay. So along this direction. So the force experienced by that will be in this direction. This is your F2. Now what is the force experienced by charge 3? This will be along this direction. This is F3. Now what is the force experienced by charge 4? This will be along this direction. So it is F4. What is the force experienced by the charge 5? So this will be in the opposite direction. It is F5. Okay. Now you can see F1 and F5 are equal and opposite. F1 and F5 are what? Equal and opposite. So we can write forces F1 and F5 are equal and opposite. So they cancel each other. Okay. Now coming to F3 and F4. F3 and F4 are inclined at an angle. What is the angle? Here this angle is 180 degree. So this is 90 degree. This is how much? 90. So this is how much? 45 degree. So this is how much? 45 degree. Now I am going to resolve F1, F2 and F4 into its two components. F2 and F4 into its two components. That is the horizontal component and the vertical component. So what is the horizontal component? So the horizontal component will act along this side, this line. So the horizontal component here it is F2 cos 45 degree. What is the vertical component? Here it is F2 sin 45 degrees. Okay. Similarly F4. F4 is also here it is another one. F4 cos 45 degree. Here it is F4 sin 45 degrees. Now we have resolved into two components. Okay. Now here we can take it. F2 sin 45 degree and F4 sin 45 degree are equal and opposite. So we can write F2 sin 45 degrees and F4 sin 45 degrees are equal and opposite. So they cancel each other. Okay. Now what is the total force? Now what is the total force? The total force is due to these three only. 1, 2, 3. Now what are the things? F3 plus F2 cos 45 degree plus F4 cos 45 degrees. Now, we'll write the F3. F3, force is equal to 1 by 4 pi epsilon 0. Okay. Instead of taking 1, I am going to take it as K itself. I am going to take it as what? K itself. Okay. So, I will write it as K into, here it is, K into QQ. One charge is capital Q, another charge is small q, by the distance is what? R square, plus F2. F2 is also what? K Q Q by R square into cos 45 degree, plus F4 K Q Q by R square into cos 45 degree. Now this can be written as KQQ by R square plus KQQ by R square into 1 by root 2 plus KQQ by R square into 1 by root 2. Now this can be written as, this is 1 plus 1, 2. So it is KQQ by R square plus 2 times KQQ by R square into root 2. So this root 2 and this will cancel. So you will get a root 2 here. So what will you get? Here it is. I'll take KQQ by R square outside. Say KQQ by R square is outside. That is 1 into 1 plus what? Root 2. 1 plus what? Root 2. So what is your total force? F total. If you write it in vector form, F total is equal to KQQ by R square into 1 plus root 2 Newton. And what is the direction of this vector? This vector, the F total force is acting in this direction itself. So it is the F total force. So that is in the positive I direction. So this is the answer you are getting. That is the total force acting on the charge small q which is placed at the center of the semicircle.